everyone. This is D. Ramarao from SRRS Government Polytechnic, Sirsilla. Today, we discuss about Arrhenius acid-base theory. Acid and base. What is acid? What is base? How it is defined? Acid and base. What are the characters of acids and bases? How do we remember acids and bases easily by identifying Arrhenius acid-base theory? What is neutralization reaction? Those topics we discuss in this hour. Arrhenius acid-base theory. Objectives. After the end of this period, you would be able to know about Arrhenius acid, Arrhenius base, Arrhenius neutralization. What are the limitations of Arrhenius acid-base theory? Those topics we discuss in this hour. Understand Arrhenius concept of acids, bases, salt. After the end of this period, you would be able to know about Arrhenius acid, Arrhenius base, Arrhenius salt, Arrhenius neutralization, Arrhenius theory, the limitations discussed in this hour. Arrhenius concept. Arrhenius concept. Arrhenius concept. Arrhenius acid. Arrhenius acid. A substance which gives H plus ions when dissolved in water is called an acid. What is acid? A substance which gives H plus ions when dissolved in water is called an acid. Any substance which is dissociated in water, it produces H plus ions, is called Arrhenius acid. A substance which gives H plus ions when dissolved in water is called an acid. Like example, HCl, hydrochloric acid, H2SO4, sulfuric acid, HNO3, nitric acid, CH3COH, acetic acid. Arrhenius base. Arrhenius base. A substance which gives H plus ions when dissolved in water is called an acid. Now we discuss base. Arrhenius base. A substance which gives OH minus ions when dissolved in water is called a base. A substance which gives OH minus ions. OH minus ions means hydroxyl ions. When dissolved in water is called a base. When dissolved in water is called a base. Like example, sodium hydroxide, NaOH, KOH, potassium hydroxide, magnesium hydroxide, MgOH taken twice, aluminum hydroxide, AlOH taken thrice. These are Arrhenius bases. Arrhenius acid. Substance which dissociated in aqueous solution which produce H plus ions is called acid. Like example Ha dissolved in water. It produces H plus ions plus A minus ions. So it gives H plus ions when dissolved in water. This substance is called acid. Is called acid. Arrhenius base BOH gives rise B plus OH minus. Arrhenius base substance which dissociated in aqueous solution it produces hydroxyl ion is called base. B plus OH minus ions. B plus OH minus ions. It gives OH minus ions in aqueous solution is called base. Arrhenius acid it produces H plus ions in aqueous solution. Which produces OH minus ions in aqueous solution is called base. Like BOH minus. BOH minus means B plus OH minus. B plus OH minus ions. These OH minus ions produced in aqueous solution is called base. Like example hydrochloric acid HCl. HCl dissociated in aqueous solution it produces H plus ions and OH minus ions. H plus ions plus OH minus ions. It produces H plus ions. So these HCl act as Arrhenius acid. Like HCl hydrochloric acid. According to Arrhenius theory, substance dissociated in aqueous solution it produces H plus ions in aqueous solution is called acid. So hydrochloric acid it produces H plus ions in aqueous solution. So these components act as Arrhenius acid. Like example another one H2SO4 sulfuric acid. This sulfuric acid dissociated in aqueous solution to form 2H plus SO4 minus 2. 2H plus SO4 minus 2. So 2H plus ions produced in aqueous solution H2SO4 act as Arrhenius acid. Arrhenius acid. HCl and H2SO4 both components act as acids. Base NaOH sodium hydroxide. Sodium hydroxide dissociated in aqueous solution it produces OH minus ions in aqueous solution is act as Arrhenius base. Arrhenius base sodium hydroxide produces OH minus ions in aqueous solution. So these components act as base. Like another example ammonium hydroxide. It dissociated NH4 plus OH minus ions. NH4 plus OH minus ions. OH minus ions produces in aqueous solution sodium ammonium hydroxide act as Arrhenius base. Neutralization reaction. What is neutralization? The reaction between an acid and a base is known as neutralization. The reaction between an acid and a base is known as neutralization. According to Arrhenius theory, substance which is dissociated in aqueous solution, it produces H plus ions is called acid. Like example, HCl. Arrhenius base, substance dissociated in aqueous solution, it produces hydroxyl ions is called Arrhenius base. Like example, sodium hydroxide. These acid of HCl and base of NaOH both react together to form salt and water. Reaction is called nucleation reaction. The reaction between acid and base to form salt and water is called nucleation reaction. According to Arrhenius, acid and base react together to form salt and water. Reaction is called Arrhenius nucleation reaction. The reaction between acid and base to form salt and water. Reaction is called nucleation reaction. For example, sodium hydroxide plus HCl gives NaCl plus H2. Sodium hydroxide base HCl acid to form NaCl plus H2O, salt plus water. Sodium hydroxide plus HCl to form NaCl plus H2O. The reaction between an acid and base to form salt and water is called nucleation. According to NaOH base, HCl acid react together to form NaCl salt, H2O water. NaCl, sodium chloride plus water. This reaction is called nucleation reaction. Actually, free H plus ions do not exist in water. According to Arrhenius, which is dissociated in aqueous solution to produce H plus ions is called acid. But H plus ions do not exist in water. These H plus ions react to water to form H3O plus ion, hydronium ion. So these H plus ion do not exist in water. They combine. What are they? H plus ions. Combine with solvent molecule that is hydrated to form hydronium ion. For example, H plus ions react with water to form H3O plus ion, hydronium ion. The ionization of acid in aqueous solution should be represented as the ionization of acid in aqueous solution should be represented as HCl plus H2O gives H3O plus Cl minus. Cl minus. The ionization of an acid in aqueous solution should be represented as HCl react with water to form H3O plus Cl minus. Limitations of Arrhenius concept: it is applicable only to aqueous solution. It is applicable to only aqueous solution. The concept could not explain the properties of acids and bases. It is applicable only to aqueous solutions. It is only using of aqueous solution. The substance which is dissociated in aqueous solution, those compounds nature should explain according to Arrhenius theory. Like HCl, H2SO4, NaOH, KOH, ammonium hydroxide, acetic acid, those compounds dissociated in aqueous solution to produce H plus or OH minus ions is called acid and base according to Arrhenius theory. Some substances do not dissociate in aqueous solution like benzene, chloroform. Those compounds nature should not explain according to Arrhenius theory. The concept could not explain the properties of all acids and bases, which is dissociated in aqueous solution. Those compounds nature explain according to Arrhenius theory. It failed to explain acidic nature of aprotic compounds such as it is failed to explain aprotic compounds such as sulfuric acid, sulfur dioxide, sulfur oxides, nitrogen oxides of nitrogen dioxide, carbon oxides of carbon dioxide, phosphor oxides of phosphorus pentoxide P2O5. It should not explain acidic nature of oxides, sulfur dioxide, nitrogen dioxide, carbon dioxide, phosphorus pentoxide. It failed to explain basic nature of oxides like ammonia, sodium carbonate, sodium oxide, calcium oxide, magnesium oxide. Those compounds nature should not explain according to Arrhenius acid-base theory. It failed to explain acidic nature of certain salts such as aluminum trichloride AlCl3. AlCl3. Arrhenius theory of acids. Arrhenius was a Swedish chemist put forward a theory of acids in the 1880s. An acid is a substance that dissociated in water to form H plus ions. Arrhenius theory of acid, for example, when HCl is added to water to form HCl, dissociated in water to form H plus ions plus Cl minus. In general, Ha gives H plus A minus. H plus A minus. Acids. HCl and HNO3 are monobasic acids as they donate one H plus ion. HCl and HNO3 are monobasic acids as they donate one H plus ion. HNO3 gives rise H plus NO3 minus. H2SO4 is a dibasic acid as it donates 2 H plus ions. H2SO4 gives rise to H plus SO4 minus 2. H3PO4 is a tribasic acid as it is donate 3 H plus ions. H3PO4 gives rise 3H plus PO4 minus 3. HCl dissociated in aqueous solution, it produces only one H plus ions. So these components act as monobasic acids. H2SO4, it produces 2 H plus ions in aqueous solution. These components act as dibasic acid. H3PO4, it produces 3 H plus ions in aqueous solution, is called tribasic acids. Monobasic, dibasic, tribasic acids. A strong acid is one which dissociated fully in water. Like example, HCl, H2SO4, HNO3, HClO4, these all are strong acids. These substance completely dissociated, it produces H plus ions in aqueous solution. These components act as strong acids. Which is completely dissociated, it produces more number of H plus ions, is called strong acid. HCl dissociated in aqueous solution to form H3O plus Cl minus. A weak acid is one which does not fully dissociated in water. CH3COH to form CH3CO minus plus H3O plus. It is partially dissociated. In aqueous solution, it produces less number of H plus ions in aqueous solution, is called weak acid. Which is completely dissociated, it produces more number of H plus ions in aqueous solution, is called strong acid. Which component partially dissociated, it produces less number of H plus ions in aqueous solution, is called weak acid. Strong acid produce more number of H plus ions. Weak acid produce less number of H plus ions in aqueous solution, is called weak acid. Strong acid, weak acid. Arrhenius theory of bases. Arrhenius defined a base as a substance that dissociate in water to produce OH minus ions. OH minus ions. For example, NaOH, KOH is added to water to produce Na plus OH minus. In general, XOH gives X plus OH minus ions. A strong base is one which dissociated fully in water. Like example, sodium hydroxide. A weak base is one which does not fully dissociated in water. Magnesium hydroxide. Sodium hydroxide, magnesium hydroxide. Arrhenius theory. Arrhenius theory. Ha gives rise H plus A minus. XOH gives X plus OH minus ions. Ha acid. It is dissociated H plus A minus. XOH dissociated X plus OH minus. XA acid, XOH base. XA dissociated H plus A minus. XOH gives rise X plus OH minus. HA acid, XOH base react together to form AX, anion of acid, cation of base. React together AX plus H2, cation of acid, anion of base. React together to form H2O. HA dissociated H plus of cation, A minus of anion. XOH dissociated X plus cation, OH minus anion. Both combine together acid HA base XOH, then form cation of base anion of acid to form AX plus cation of acid anion of base react together to form H2. Then cation of base express anion of acid A minus react together to form AX. Cation of acid H plus anion of OH minus to form H2 water. HA plus OH minus XOH gives rise AX plus H2. Acid and base react together to form salt and water. This reaction is called neutralization reaction. Limitations of Arrhenius theory. The acids and bases must be in aqueous solution. This prevents the uses of other solvent benzene. This theory must be explained in aqueous solution like water. This prevents the use of other solvent like benzene. This theory explains which is dissociated in aqueous solution. It produces H plus or OH minus ions. Compounding nature should be explained according to Arrhenius theory. It failed to explain non-aqueous solutions like benzene, chloroform, carbon tetrachloride. Those compounding nature should not explain according to Arrhenius theory. Not all acids base reactions are in solution. For example, ammonia gas and hydrogen chloride gas produce ammonium chloride. Not all acid-base reactions are in solutions. It explains only which is dissociated in aqueous solution. Those compounding characters depends on Arrhenius theory. But some gases are involving as acid and base to form salt and water is neutralization reaction, but this theory could not explain those reactions. Ammonium gas and hydrogen chloride gas produce ammonium chloride, salt. Acid and base reactions are in solutions. For example, ammonia gas and hydrogen chloride gas produce ammonium chloride. According to Arrhenius, the salt produced should not be acid or base. This is not always the case. For example, in the above reaction, ammonium chloride is slightly acidic, that is acidic nature. Summary. Acids gives H plus ions in aqueous solutions. Acids produces H plus ions in aqueous solution. Base gives OH minus ions in aqueous solution. Acids, substance which is dissociated in aqueous solution, it produces H plus ions in water is called acid. Acid gives H plus ions in aqueous solution. Those acids like HCl, H2SO4, CH3COH, HClO4, HCOOH, these all are acids. The substance completely dissociated, it produces more number of H plus ions in aqueous solution is called strong acid, like HCl, H2SO4. The substance partially dissociated in aqueous solution, it produces less number of H plus ions in aqueous solution is called weak acid, like CH3COH, HCOH, H2CO3, so on. These acids are two types. One is strong acid, another one is weak acid. Base. Base gives OH minus ions in aqueous solution. Substance dissociated in aqueous solution, it produces OH minus ions in aqueous solution is called base, like NaOH, KOH, ammonium hydroxide, magnesium hydroxide, calcium hydroxide, these all are bases. A substance completely dissociated in aqueous solution, it produces more number of hydroxyl ions is called strong base. Substance completely dissociated in aqueous solution, it produces more number of OH minus ions in aqueous solution is called strong base. Like example, sodium hydroxide, potassium hydroxide, so on. A substance partially dissociated in aqueous solution, it produces less number of OH minus ions in aqueous solution is called weak base, like ammonium hydroxide, calcium hydroxide, so on. Acid and base. Acids are strong acid, weak acid. Bases are strong base, weak base. Acid and base combine to form salt. Acids, strong acid, weak acid. Base, strong base, weak base. Acid and base react together to form salt and water is called neutralization reaction. The reaction between acid and base to form salt and water is called neutralization reaction. Like example, HCl plus NaOH gives rise NaCl plus H2. HCl acid. According to Arrhenius, HCl produce H plus ions is act as acid. NaOH base. According to Arrhenius, NaOH produce hydroxyl ions in aqueous solution is called base. Acid of HCl, base of NaOH. These HCl produce H plus ions plus chloride ions. NaOH produce Na plus cations, OH minus anions. OH minus anions. That is ionization of acid and base. Both react together to form cation of base, that is Na plus, anion of acid, Cl minus. These Na plus and Cl minus react together to form NaCl salt. sodium chloride plus cation of H plus and anion of OH minus ions react together to form H2O water. HCl acid NaOH base. These both react together to form NaCl plus H2. NaCl plus H2. Acid base neutralization reaction, which is Arrhenius acids. Which is Arrhenius acids. A. Carbon dioxide. B. Sulfur dioxide. C. Sulfur trioxide. D. HCl. Carbon dioxide, sulfur dioxide, sulfur trioxide, hydrochloric acid, which is Arrhenius acid. What is Arrhenius acid? Substance dissociated in aqueous solution, it produces H plus ions, is called Arrhenius acid. CO2, SO2, SO3 absence of H plus ions. Those substance could not presence H plus ions. So this component does not act as Arrhenius acid. HCl produce H plus ions when dissociated in aqueous solution is called Arrhenius acid. According to Arrhenius, substance dissociated in aqueous solution to produce H plus ions is called acid. Carbon dioxide, sulfur trioxide, absence of H plus ions, so this compound does not act as Arrhenius acid. But CO2, SO2, SO3s are act as acidic nature. According to Arrhenius, the substance which is act as acid, those components present H plus ions. This HCl presence of H plus ions, it is act as Arrhenius acid. Carbon dioxide, sulfur trioxide, absence of H plus ions. So this component does not act as Arrhenius acids. HCl act as acid. According to Arrhenius acid, HCl, Arrhenius acid, CO2, SO2, SO3 does not act as Arrhenius acids. Answer is D. HCl, hydrochloric acid. It is act as acidic nature. Second question, which is Arrhenius base? What is Arrhenius base? The substance which is dissociated in aqueous solution to produce OH minus ions in aqueous solution is called Arrhenius base. Arrhenius base, which is act as Arrhenius bases, like ammonia, NH3, calcium oxide, sodium hydroxide, HCl. Arrhenius base. The substance which is dissociated in aqueous solution to produce OH minus ions is called base. Ammonia, dissociated, it does not produce OH minus ions. Calcium oxide, it does not produce OH minus ions. Sodium hydroxide dissociated Na plus OH minus ions. HCl, it is dissociated H plus and Cl minus ions. So sodium hydroxide act as Arrhenius base. HCl act as Arrhenius acid. Ammonia and calcium oxide, these components act as basic nature, but to fail you explain about those compounding basic nature. Arrhenius base, substance dissociated in aqueous solution to produce OH minus ions. So sodium hydroxide act as Arrhenius base. HCl act as Arrhenius acid. Ammonia and calcium oxide, generally these compound basic nature, but according to Arrhenius, substance produce OH minus ions. So sodium hydroxide Arrhenius base. Which is Arrhenius base? Ammonia, calcium oxide, sodium hydroxide, hydrochloric acid. So sodium hydroxide Arrhenius base. NaOH, sodium hydroxide Arrhenius base. Third one, Arrhenius failed to explain the acidic nature of. Arrhenius failed to explain acidic nature of carbon dioxide, sulfur dioxide, sulfur trioxide, above all. Arrhenius failed to explain the acidic nature of CO2, carbon dioxide, SO2, sulfur dioxide, SO3, sulfur trioxide, above all. Arrhenius failed to explain the acidic nature of oxides of bases. Oxides of carbon, sulfur, nitrogen, those components act as acids like CO2, SO2, SO3, N2O5, P2O5. These all are act as acids. According to Arrhenius, substance which is dissociated in aqueous solution to produce H plus ions. But carbon dioxide, sulfur dioxide does not present H plus ions. These components generally act as acidic nature. But according to Arrhenius, does not act as acids. Carbon dioxide, sulfur trioxide, these all are acids. But he failed to explain above these compound acidic nature. So CO2, SO2, SO3, these all are acids. Arrhenius failed to explain the acidic nature of carbon dioxide, sulfur trioxide. Answer, above all. Frequently asked question above this topic. Arrhenius acid base theory. Frequently asked questions. State and explain Arrhenius theory of acid and base briefly. Arrhenius acid and base briefly. State and explain Arrhenius theory of acid and base briefly. Arrhenius acid. What is acid? Substance produce H plus ions in aqueous solution acid like HCl. What is base? Substance dissociated OH minus ions in aqueous solution is called base like NaOH. What is neutralization? Reaction between acid and base to form salt and water. Neutralization. HCl plus NaOH to form NaCl plus H2. Limitations of Arrhenius acid-base theory. Explain neutralization reaction. The reaction between acid and base to form salt and water is called neutralization reaction. Like HCl plus NaOH to form NaCl plus H2O. This is our topic today: acids, bases, neutralization, and limitations of Arrhenius acid-base theory. Like, which is dissociated in aqueous solution to produce H plus or OH minus ions depends on strength of acid and base. Thank you once again. Today's our topic Arrhenius acid-base theory.